All right, hello, welcome to fourth quarter. I feel like I'm talking to you in the future because right now it's March 24th and you're probably not going to watch this until April 12th, but that's okay. So this video is going to walk you through the week 1 Google Doc. It's long. You don't have to do it all at once, but do not put it off until like Sunday, for example. You will regret it. Just to be clear, this week you have 2 assignments that are due. One of them is the week 1 Google Doc, and I'm going to be walking you through that in this video. The other is on AP Classroom. It's the Unit 5 Multiple Choice Part A. These assignments are due Sunday, April 18th at midnight. Okay, so the Google Doc is pretty long. We're going to take it one part at a time. For timing, like if you can get through like part 1 and 2, maybe start part 3 on either Monday or Tuesday, then, continue that on Wednesday and then finish up the Google Doc on Thursday, Friday. And then you'll have a little bit of time to do part A of the multiple choice review as well. All right, so we're going to start with part 1. We're going to look at how did the chapter 4 test go, unit 4. So today we're going to be taking a sample from that population. You'll see these words are bolded. Population means everyone, and sample is just a small selection out of everyone. So we're going to start with a very simple example. Let's pretend I have a 5th hour stats and that there are only 4 students in the class. Their scores are listed there, 7, 5, 4, and 0. First thing I want you to do is to make a dot plot of the population distribution. And then also take a sample of any 2 of the scores and find the mean of your sample. For the dot plot, you can either sketch it out, that's totally fine. You can also go to Stapplet and copy paste that in. Go ahead and pause here and work through those 2 problems. When you're ready, you can hit play and we'll go over them. All right, so going over questions 1 and 2, making a dot plot. I'm just going to sketch it out rather than using an official Stapplet dot plot, but either one is cool. Okay, so I have one person who got a 0, I've got a 4, and a 5, and a 7. So your dot plot should look something like that. Take a sample of any 2 scores, so you can pick, I'm just going to pick the first 2. Find the mean of your sample. So add them up, divide by 2. In this case, I get 6 for my mean. You can have a different answer based off of you picking 2 different scores. Maybe you picked 7 and 5 as well. Most likely you picked something different. So either way is fine. All right, so here I want you to try to work through 3, 4, and 5, and we'll go over those when you're ready. So go ahead and pause, and then when you're ready, hit play, and I'll walk you through the answers here. All right, so question 3 is asking you to find all of the possible samples of size 2 and calculate the mean for each. I sort of wish I had the scores on this. So 7, 5, 4, 0. Okay. So for question 3, we're trying to figure out all the different possible samples of 2. So I could have 7 and 5, like I already did, 7 and 4, 7 and 0. I could have 5 and 4, 5 and 0, and I could have 4 and 0. So that's all of the possible samples of size 2. Calculating the mean for each one. Let's see, 7 plus 5 is 12. Divide that by 2, we get 6. 7 and 4 is 11, but if I divide that by 2, it's 5.5, 3.5, 4.5, 2.5, and 2. All right, so that's all question 3. We listed out all the possible samples of size 2, and we calculated the sample mean for each of those. All right. From here, I ask you to make a dot plot of those means and paste it, and then also find the mean of the population, label that on your dot plot. I'm going to go ahead and do that together down here. I'm not going to use Stapplet because I'm just writing on my iPad, but I'll make a nice sketch. You can certainly do that as well. Let's see, it looks like my means are going from 2 up to 6. I'm going to try to put these as to scale as I can. All right. I'm just plotting all of the means. Okay, cool. So we graphed all of the means Next up, it's asking us to find what's the mean of the population. So the population here was quite small. It was just 4 students, right? So my 4 students had gotten 7, 5, 4, and 0 as their scores. If I'm trying to find the mean for the population, I'm going to add all of those up. That gives me 16, just checking, yep. And then I'm going to divide that by 4. So I'm getting my final mean of 4. I'm asking you to label this on your dot plot. If you just have a screenshot, that might be kind of difficult, but I want you to see where that looks, or what that looks like. Hopefully you're seeing that it looks right in the middle. It should be. For this, because we were looking at the whole population, the mean of all of those samples should equal the mean of our population. And we'll get to that in a minute as well. All right, so that's actually it for the questions. We're going to do some notes and then do a check for understanding. So we have a few things to talk about. So first thing are parameters versus statistics. I feel like we've talked about this, but I might just be thinking about last year, so like last school year. So I'm just going to talk about it again. A parameter is a number describing a population. And a statistic is related, but it's a number describing a sample. So way that I remember this is parameter starts with P and so does population. Statistic starts with S and so does sample. And just real quick, the difference between population and sample. Population is everybody. Sample is a selection from everybody. Okay, next thing I want to talk about is sampling distribution. Sampling distribution shows the statistic found in all possible samples of a certain size. So whatever size it is up, and the activity we used size of n equals 2, our samples were each 2. So a sampling distribution, we will often be using a dot plot. So I'm just going to draw like a random dot plot here. If you're just looking at any one specific dot, that is telling you the statistic from one sample. So if you go up and if you look at the dot plot we made, each dot was showing us the mean of one sample. Okay, the last vocab word for part 1 is unbiased. And this is a word you're familiar with from settings outside of statistics, but it has a specific meaning in statistics. And I know we talked about like biased surveying methods earlier. This is even a little more specific. So a statistic, and remember a statistic is a number describing a sample. It could be a mean, it could be standard deviation, it could be whatever number we're looking at that's describing our sample. Okay, a statistic is unbiased if the mean of the sampling distribution is equal to the parameter. We'll get into this a lot more. So basically, like trying to put this in less mathy words, if what you're getting from your sampling distribution is equal to the true parameter is like the true number describing a population, we say it's unbiased. And then just one last thought with that before we jump to our check for understanding. When you increase sample size, the sampling distribution variability goes down. So in this simple situation where I had samples of 2, if I did samples of 3, like the dot plot would be closer together. And that to me is sort of logical. Like if you're taking bigger samples, they're going to be more accurate. They're going to be less like pulled in one way versus the other. All right, so we're almost done with part 1. Please take a moment to get as far as you can on the check for understanding. I will go over answers on that in a bit. Well, I'm not going to wait, but you should pause the video. Throughout all of these lessons that I'm recording in advance, I know there might be a temptation just to like hit play, fill out your doc, move on with your life. I'm just going to encourage you that that's not actually going to help you learn it. Like, you've probably all sat in my class before and like watched me do stuff, and then when it comes time for you to do it on your own, you have no clue what to do. I don't want that to happen to you. So please try it. It's okay to make a mistake. It's okay to get stuck. That's totally fine. Maybe you can answer part, A through B, and that's it. And that's great. Like, you tried it, you got as far as you could. That's so much more valuable than you sitting and just watching me do it. So please pause, and when you're ready, we'll go through the check for understanding together. All right, so check for understanding. First of all, it's just asking you to list the 10 possible samples of size n equals 2 from the population, and then calculate the sample mean age for each sample. The first one is done. So this is J and A, that's Jocelyn and Elise. They're both 8. The mean there is 8. Okay, so I'm going to list out my other possible samples. I could have Jocelyn and Michael, Jocelyn and Erica, or Jocelyn and Sarah. And then that's it for my Jocelyns. For Elise, I could have Elise and Michael, Elise and Erica, Elise and Sarah, and that's it for her. I could have Michael and Erica, Michael and Sarah, or Erica and Sarah. For each of these, I have to calculate the mean from the sample. Okay, so if I'm going to start here, that's Jocelyn, who's 8, and Michael, who's 14. So if I add those up, I get 22, and then I need to divide that number by 2. So my mean here would be 11. If I'm finding the mean between Jocelyn and Erica, if you add up those 2 ages, you get 24. The mean is 12. For Jocelyn and Sarah, we have a mean of 13. I'm just going to go ahead and fill in the other means here. All right. Here, for B, it's asking us to create a sampling distribution. This is going to look like a dot plot of the sample mean age of samples of size 2. All right, so I'm going to sketch mine out like down here, I suppose. So it looks like my means are going, my lowest mean is 8, my highest mean is 17, so I want to make sure I have space for all of that on my dot plot. And you can certainly use Staplet for this, that's totally fine. All right, so I'm going to go ahead and sketch this out. I've got 8, I've got 2 11s, I've got 2 12s, 2 13s, no 14s, I've got 15, 16, and 17. All right, so that's all we need to do for our sampling distribution. I suppose we can label it. This is called the sampling distribution of X. All right. For question C, it's asking us what is the mean of the sampling distribution of the sample mean, and then also what is the mean of the population. So these questions might seem pretty similar. They're a little bit different though. So this first part, I'll color code. If we're trying to find the mean of the sampling distribution, that's going to be the mean of all of this. So that is going to be, I'm going to write that out as mean of X bar. That's what we call it. It's an X with a bar on it. And it's going to be all of those means from the sampling distribution. So 8 and 11 and 12. I'm just going to do a dot, dot, dot. all the way up to 17. So we're going to add all of those. And there are 10 samples, so I'm going to divide that by 10. When you do that, we should be getting to 12.8. Okay, so that's the first question. The second question here, what is the mean of the population? The population here is just the 5 kids. So my mean is going to be, let's see, I've got 2 8-year-olds, 14, 16, and 18. I'm going to divide that by 5 because there's 5 kids. And that is also 12.8. So if you got stuck and you're watching the video, I think I would encourage you to try D&E now that you have the stuff solved for you. You might be able to make a little more progress on it. And then you can start playing the video again when you're ready. For question D, it's asking us, is the sample mean? Is it an unbiased estimator of the population mean? And here we can say yes. If you look back at our notes, unbiased means that the mean of the sampling distribution is equal to the mean of the population itself. And we showed that. We got 12.8 and 12.8. So I can say yes, the mean of the sampling distribution of X bar is equal to the population mean. All right, and then last part for this. Suppose we had taken samples of size 3 instead of size 2. Would the variability of the sampling distribution be larger, smaller, or the same? And this is based off of that last little thing I gave you in your notes where it says, when increasing sample size, the sampling distribution variability decreases. So if n is now 3 instead of 2, if my sample size increases, that means that my variability will be smaller. All right, so that's part 1. I'm going to go ahead and stop this video now so that way you can try to take breaks as needed. When you're ready, go ahead and start part 2.